My name is Magneticus Julius. My matrix number is AW150180. I'm from mutation and I am currently taking degree in applied physics.
My name is Ainahana Budi and my matric number is 150077 and I'm a third year student of applied physics in UTHM.
Hi, my name is Chuzili. I'm from UTHM and I'm currently pursuing applied physics and then I'm a year 3 student. My matrix number is AW150254.
My name is Amirul Ilfi Begazali. I have HM in applied physics and a third year student. My matric number is AW150137.
Today I will explain to you about the process of the nuclear reactor and then the outcome of the nuclear reactor after the process.
The nuclear reactor is the source of intense heat which is in turn used for generation of power in nuclear power station. There are two main types of nuclear reactor, which is boiling water reactor and pressurized water reactor. Focusing on PWR, zooming inside there we have reactor core, which is the sets of fuel elements, moderator and also the control rods. Inside the control rods we have uranium-235 atoms that compose of protons, and neutron is unstable. As nuclear breaks up, there will release neutrons and hit another uranium atoms. Thus, fission occur and then will produce the chain reaction. The chain reaction will produce more heat, at which each neutron carry 1 mega electron volt. This will make the fuel rods heats up as the effect of the chain reaction. And then at the same time, the control rods will absorb neutrons and moderate the reaction rate. This will result to the pressurized water loop where steam is generated. The steam will flow all the way through the turbine. And at the same time, the steam is used to drive turbines, and at the same time, condensed water returns to be reheated as the process is cycling and the turbines drive generators and produce massive electricity. This big and massive electricity will brings up and flows to national grid. Then it will distribute it to all appliances needed to the whole wide nations.
Actually, I will be explaining about nuclear reaction, which is nuclear fission and nuclear fusion.
Today I'm going to present about types of radiation. There are three types of radiation. The first one is alpha. Alpha radiation is very easily stopped. It just can be stopped by air or by just a piece of paper. When alpha is an magnetic field, it bends right a lot. This bending shows its property, which is the heaviest radiation and it is most charged. This is the symbol of alpha, and it is not penetrating. The next one we're going to talk about is beta. Beta is more penetrating than alpha, and it can be stopped by 1/2 centimeter of aluminum. In magnetic field, when alpha bend right, beta bend to the left. This bending shows that it is much lighter than alpha and it is also negatively charged. This is the symbol of beta. And last and final one is gamma. It is the most penetrating and it goes further in air. It cannot be stopped by half centimeter of aluminum, but it can be stopped by lead. Gamma is not a particle. It is a wave of pure energy. It has no charge and no mass.
Later, I'll be explaining to you more about the proper ways to dispose the nuclear waste. Many fields are relying on the nuclear technologies that use radioactive materials. The benefits of these technologies, whether used in agriculture, industry, or medicine, are plentiful. Like other processes, they generate waste. These wastes contain radioactive elements. People and the environment must be protected from the potential hazards of such waste now and in the future. So, countries need to manage their radioactive waste safely and securely and make sure they are kept under control. This responsibility starts as soon as a country decides to use nuclear technologies. Techniques are available to manage radioactive waste. Radioactive waste is classified depending on the half-lives and the level of radioactivity of the nuclides. According to the IAEA's safety standards, there are 6 classes of radioactive waste as shown. Each waste class has different management and disposal needs. Techniques exist to manage this radioactive waste and the spent nuclear fuel from power plants and research reactors in a safe and secure way. Waste containing only radionuclides with very short half-lives can be stored for a few days or years to allow for the decay of the nuclides. This type of waste is usually generated when radioactive materials are used for research or medical purposes. Eventually, it can be disposed of as conventional waste. Other waste forms needs to be managed for radioactive waste disposal. By volume, most radioactive waste has low levels of radioactivity. This includes the majority of the waste that comes from the routine operation of a nuclear power plant and waste that's produced when medical and industrial devices that use radioactive sources are no longer needed. This could be because the source has decayed and the remaining radioactivity isn't strong enough for its original purpose, or the device is damaged or obsolete. In these cases, the radioactive source needs to be removed from the equipment and prepared for the storage and eventual disposal. Some countries process their waste at centralized waste management and storage facilities. Upon arrival, the waste is controlled to check for any surface contamination and the radiation levels are measured. Details of the waste type are noted for the inventory before the waste can be processed further to prepare for the storage and disposal. Such processes can involve measures to reduce the volume of waste, such as compaction and incineration. Capsulation is used to immobilize the contaminants. After being placed in appropriate containers, the waste is stored. It will remain in the kind of facility until a suitable place or system for its disposal is established. Many countries already have near-surface disposal sites for waste with low levels of radioactivity. In all countries generating nuclear power, the spent fuel is currently stored either in water pools or dry cask at secure storage facilities. Waste management experts around the world agree that underground geological disposal is the preferred option as a solution for high-level waste and spent nuclear fuel.
Later, I will be explaining about the application of nuclear reactor.
Let's explore the application that may occur in the real world around us. Nuclear energy can be found almost every field of research, from medicine to the agriculture. There are many different applications of nuclear energy exist due to the special part of nuclear energy, which is known as radioisotopes. What are radioisotopes? Isotopes are the different forms of an atom with the same chemical element. They have identical chemical properties but different in atomic mass. The number of protons exists is the same, but the number of neutrons in the nucleus is different. Due to its stability, they were referred as radioisotopes, which allow them to have many uses in today's modern science and technology. So the radioactivity is used as a tag to follow the movement of the material incorporating item. Other applications of nuclear energy are food, agriculture, water resources, medicine, and industry around us. In food agriculture, radioisotopes can be found in two things, which are fertilizers and increasing genetic variability. Fertilizers have two kinds of isotope, which are nitrogen-15 and phosphorus-32. This isotope manage the amount of nitrogen at the plant from the air or the root. Increasing genetic variability is the process of using radiation to induce mutation of a plant in order to produce new genetic lines, root beer crops, cereals, oilseed crops, and many different vegetables and plants. It includes special technique, which is sterilized insect technique (SIT). This involves initial large number of insects and irradiating the air with gamma radiation before they hatch to sterilize them. When the male and female are now off to produce by SIT, the population of insects are reducing.